Greetings to all of you. Today we are going to cover an important topic of physics 5054, which is transformer. So this is basically a topic of electromagnetic induction. And we will thoroughly understand that how does a transformer is constructed and what is the analogies that are used here, what are the types, what is the cell construction, and what is the principle of transformer. So as the name refers, a transformer means that it transforms something. So it transforms voltage. So voltage transformation might be of two possibilities. The first one is that it should transform low voltage to high voltage or high voltage to low voltage. So both the cases we will discuss in transformers. So if a transformer transforms the low voltage in a higher voltage, then we will name it as step up transformer. And if it converts high voltage into low voltage, we will name it as step down transformer. So what are these and how that work, we will discuss it in later topics. So till now we have studied the transformers. As the name refers, it transforms voltage from lower to higher and higher to lower. Now the second thing is that why does we need a transformer? What was the necessity before the scientists to create such a magnificent device? So the first one is that we will name this heading need of transformer. So as you know, by the mathematical expression of power losses, which is I square R, and we know that for long distance transmission we have a network of wires, and due to the long length of these wires, the value of R, as the R is directly proportional to the L and the L is the length, the resistance will increase. So for long distance transmission of electricity, Tesla and Edison were the scientists before the transmission line, AC and DC voltage. So these scientists found that the power losses are very great. So to minimize these power losses, we created transformers. So what is the principle? So the principle that is used in transformer is the electromagnetic induction. So what does it mean? We will discuss it in a later later discussion. So till now we discussed about transformer, its types, and why we need a transformer, and what is the principle before this. So what does it mean by induction? So let's suppose we have a coil. Let's say we have a copper coil and another coil that we placed at some distance. Please do note that there is no physical contact between both of the coils, and we connect a galvanometer to one of the coil and a source, a AC source. So the portion to which we will connect our AC source is named as primary coil, and the other one is named as the secondary coil. So by changing the potential here, we will see that this fluctuation in this flux in the electric field will induce current here, will induce voltage here. So if we look at the mathematical expression of Faraday's law, which is the EMF, electromotive force, which is the potential, is directly proportional to the number of turns and to the change in the flux over the time change. So as you can see that the number of turns has a direct relation with the voltage or electromotive force, you can see. So if we increase the number of turns of our secondary coil, it means that we will get more voltage or electromotive force. So this condition fulfills the step down transformer, step up transformer, which is that here we have low potential and we will convert it in higher potentials. So we will discuss that while managing the voltage value, we have to compensate with the current value, as the power, you can see, that is equal to IR. So if we increase the voltage, ultimately the voltage will decrease to manage the power value constant. So what is the practical use of this is that in our power stations, we use the step up transformers, which converts the voltage to high volt and low current. And on our home supply, we used step down transformer, which lessens the voltage value and increase the current value for domestic appliances. This is the house of ours, we can see. So there are some of the mathematical expressions before this. So we can see expression or relations, we can see. So the first relation in transformer is that, as we have studied in Faraday's law, that EMF has a direct relation with the number of turns. So we can see that this direct relation, which is the voltage, if we talk about primary or secondary, the ratio of both of them will be, so this is the first mathematical expression that we will use in a later discussion. And the second one is for obvious, the formula of efficiency. So efficiency is the power that we get at our output. Output is basically the secondary coil, and the power we inputted multiplied by 100. So the power has a formula of VI. So as this refers to the secondary coils and this refers to the primary coils, this is the formula for efficiency. And if in a case we have 100% efficiency, then we will have power at output will be the power at input. So we will say that I secondary V secondary is equal to I primary V primary. So these are the three mathematical expressions that we will use in numericals and other discussions. So we will have a quick review of the discussion. So we are covering a topic of electromagnetic induction, which is the transformer. So as the name refers, transformer transforms the voltage in two manners, either in the lower to higher or higher to lower. So if it converts lower to higher, it will be step up transformer, and if it will convert higher to lower voltages, it will be stepped down. So the need of the transformer is that to minimize the power losses in our transmission system, and the principle is electromagnetic induction. And the Faraday's law refers that the EMF, or electromotive force, or the voltage has a direct relation with the number of turns. And if we create a induction pattern or induction cell, then we can see that this fluctuation in the primary coil will induce voltage to the secondary coil, and we will get our galvanometer diffracted. So we have to compensate one factor. If we increase the voltage, the current will ultimately decrease to manage the power values. So at power stations, step up transformers are used, which higher the voltage value and decreases the current value. And in our house system, or the transformer that we usually see in our local areas, are step down transformers. So these are the mathematical expression. There is one thing missing, which is the soft magnetic core. So the soft magnetic core is of great concern. You can see that this setup we have created in our free space. So this winding is not actually on a free space. This is on an iron core. So this is the actual scenario. The reason to use any soft magnetic ferromagnetic material, or usually iron, is that if you look at in the pattern for the induction, the electric field will dissipate in all the directions, but we don't need the dissipation in that side. We want all the magnetic field of lines to pass through the secondary coil. So to manage this, we have to use a ferromagnetic substance that attracts all the magnetic field of lines to pass through the secondary coil. So that is why we prefer the soft iron core, or any soft ferromagnetic material, to avoid any dissipation in that step. So this is all for today about the transformer. See you in next video. Thank you.